Okay, well, let's get started. We're talking about compound angles again today, and we're going to do a lesson that's sort of slightly more difficult than what we were doing the last time. The last time we were just talking about expanding them and then doing the reversal of the expansion. And then we also concentrated a little bit on how we would use compound angles to find the value or to determine the value of a particular expression. Okay, so that's where I wanted to start today, was just a little recap of what we had done last time, and then do a few more newer examples with you. So the last thing that we focused on was how to calculate the value of an expression, and we were applying our reduction formulae. Oh, I see Nkuleko's got a hand up. Nkululeko, do you want to ask something? Oh, Una says some of the schools are already on holiday. Oh, sorry. Oh, there we go.
Yeah, no, Kulego doesn't have audio running on his, so I'm just gonna help him
Oh,
privately.
okay, well, you just help him privately. Okay, all
Yes.
right, that's fine. So if you recall last time, sorry, I didn't put a heading in here, which is a little bit silly of me. So what we wanted to do was determine the value of this expression. Let's just get that down so that when you take screenshots and stuff, you've at least got an instruction. Okay, so if we recall from last time, when we look at an expression like this, what is the first thing that we need to think about, Matrix? When we look at the numbers and we see 65, 295, 115, 205, what's the first thing that pops into our minds before we even start thinking about compound angle formulae? What's the first thing? Reduce. There we go. Okay, so we want to think about reduction and we want to think about our cofunctions. Okay, so never, ever, ever forget about cofunctions or your special angles. They are very important in matric. Absolutely, absolutely. Okay, so am I going to reduce cos 65? No, it's already reduced. So this would be equal to cos 65. And what would I do with cos 295? How would I reduce that? What would it reduce to, Matrix? Go for Nkululeko. Your hands up.
Kululuge is the same story.
Same story.
Spoken to
Oh,
him.
okay. Oh,
Yeah,
shame.
so I'm
Okay.
not sure because he's not
All
responding.
right.
I'm not sure how we can help. Yeah.
Okay. All right. What would we do with cos 295? Please mute. Thank you. There we go. All right. So there's a couple of people with hands up. Okay, Morgan, go for it. What would you do with cos 295?
You would reduce it to cos 90 minus 25, and then it would become cos 25.
Okay, if you do 90 minus though, cos will change to sine and sine will change to cos. So just be aware of that. Often what's better, Morgan, is for you just to apply your normal reduction formulae. So 360 minus 180 plus 180 minus, and then worry about cofunctions. If you've got an acute angle and you're trying to make it into, so let's say you've got the cos of 65, but you want to write it as the sine of 25, then do your cofunctions. Okay, so it's better to treat cos 295 as an angle in the fourth quadrant, reduce it, and in this case, it would reduce to, let's just see what other people are saying. Yes, so it's going to reduce to positive cos 65 because we're working in the fourth quadrant. Okay, then when it comes to sine 115, we're in the second quadrant. Can anybody tell me what sine 115 would? And again, you can go and say 90 plus. You can if you want to, but just stay away from that for now. Rather reduce it first, and then we'll see afterwards what it is that we want to do. What would sine 115 reduce to? I think someone said it in the chat. Okay, so there we go. So 115 from 180 gives us 65, absolutely. So this would reduce to sine 65, like so. Multiply it by cos 205. 205 means we are in quadrant 3. Okay, so is cos positive in quadrant 3? No, it isn't. So whatever this reduces to, it's going to be negative. So negative cos, and we would do 180 plus, I beg your pardon, and that would leave us with 25, like so. All right, so Morgan, your suggestion from earlier was a good one because you wanted to change this, which you can do that now, but let's just clear up our signs before we go ahead and do that. So we've got the cos of 65 times the cos of 65 plus, because a negative times a negative is a positive, the sine of 65 times the cos of 25. Okay, and now we're looking at this and we're saying to ourselves, we've got cos, cos, sine, cos. We know that that is not a compound angle formula. Morgan, you had a nice suggestion. You said, let's change this into the sine of 25. Okay, which we're allowed to do. So you don't have to show that. Obviously, you have to show that you've changed it, but you don't have to show that you've used 90 plus or 90 minus, just like you don't have to show that you've used 180 minus, 180 plus, or 360 minus. Okay, so 65 and 25 are complementary angles. They add up to 90. So we can rewrite that as the sine of 25. That's not a problem for us at all. Okay, so we've got cos 65 sine 25 plus sine 65 cos 25. Now, we can see we've got cos, sine, sine, cos. We can see that it has to be a sine compound angle. Sine keeps its sine, so we're going to be adding. But if we were subtracting, it would be better to move the second term and the first term around, okay, so that we don't end up with a negative angle. All right, but in this case, it's not going to make any difference which way we do it. Okay, so we can now do the reversal of the expansion. This is going to be 65 plus 25. And if we add 65 and 25 together, we know that we get 90. So whoopsie daisy, we're talking about the sine of 90 degrees. And again, we would have to use our special angles. So the sine of 90 in this case, well, in every case, would be equal to 1. There we go. How do you guys feel about that now after we've sort of looked at this a second time? Does that make sense to everyone?
iPhone has their hand up. I'm not sure if that's a question or.
All right, that's fine. Is there? Okay, so there's a few people putting thumbs ups. That's great. All right, let's have a look. Okay, good stuff. Okay, very good. So let's move on and let's talk about the sort of question that we actually want to do now. All right, if there are any questions, I can come back to that. I'll just do this example and then we'll see, maybe we can come back to that specific one. Or maybe Nonkululeko, how did the minus change to plus? Because a negative times a negative is a positive. Okay, so over here, this negative multiplied by that negative is what gave us our positive over here. Okay, that positive over there, which I've made a bit of a mess of. Okay, so we've got to be very, very careful about signs always, 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 always. Okay, let's have a look at this example.
Ma'am, can I ask,
Sure, Maholo.
why is it sine 90 at the end?
Why? Because 65 plus 25 is 90.
Where did you get that sign?
I'm using my compound angles. Okay, so if you have a look at this line over here, that line over there, right? That's exactly the same as this over here that I'm just highlighting in pink. Okay,
Okay.
Umaholo. So all I was doing from the line with the pink arrow to the next one, I was doing the reversal of the expansion of my compound angle formula.
Okay. Thank
Okay, no problem, no problem. Okay, let's just see. Okay, so I think there were a couple of other people. Good that you asked that question. Okay, so Sharon, that's a very common question that matrics ask. What happened to cos? Where did it go? You used your compound angle formula to do the reversal of the expansion. Does that make a bit more sense now? Okay, so I promise you, it's not as though terms and maths just disappear. If a term is not there anymore, there's a good reason for it. Okay, it's because I applied the reversal of the compound angle formula. Okay, all right, let's go on and have a look. Sorry, I should have asked you guys if there were any more questions before moving off, but I think we are okay now. Another common thing that comes up in Trig a lot is where they ask us to show or prove things. Again, it's not a much more difficult, but it is a more difficult sort of higher order thing, having to prove that something's true rather than just do a simple calculation. So in this example, they ask us to show that cos 60 plus theta minus cos 60 minus theta equals minus root 3 sine theta. Last year, when you were in grade 11, we showed you, or your teacher at school would have showed you how to prove identities, right? And it's very important to understand that when we are proving an identity, we are not solving an equation. Right, we are proving that something is true, that an expression equals something else after it can be simplified. So it's not like we can do the same thing to both sides. We are working with one side only. That's the first thing. So where it says show that this equals this, you need to pick a side. Are you going to work with the left-hand side or are we going to work with the right-hand side? Hopefully by now we all realize we're going to work with the left-hand side, and what we are looking at there are some compound angles, right? So the first thing that we want to do is use our compound angle formulae and try and expand it. So I'm just going to copy those and move it down a little bit, although there isn't an awful lot of space here. Let's just put them out the way, then everybody can see them nicely. Okay, and let's just move. I always think you're going to have enough space, and then I always end up running out because I write a bit bigger than I intended to. But anyway, that's a good thing. Okay, so using our compound angle formulae, let's expand what is on the left-hand side. We are required to write left-hand side equals. Okay, so very, very important that we're not keeping the left-hand side and the right-hand side the whole way down. So I can see that this is a compound angle formula. So I'm going to go and have a look. Okay, and over here, it would be this one. So cos A plus B. So I'm going to expand it accordingly. So what is essentially one term is going to become two terms. So expanding this, I would end up with cos 60 cos theta. And then remember, cos doesn't keep its sign. So this is going to be minus sine 60 sine theta. Now, the other thing that I need to be super, super, super careful of over here, matrix, is this minus sign in the middle. Okay, remember when using compound angle formulae and you were doing an expansion, something that's one term becomes two terms. Okay, now the reason that I'm emphasizing this is because when we have got a minus in front of something and there's more than one term, we need to remember to change the signs. Okay, so what helps us to remember to change the signs are, anybody know? What should I use here? What's going to help me remember to change the signs after my minus? Absolutely favor. Okay, brackets, brackets, brackets. Right. I think in maths, we do not use brackets enough when it is appropriate for us to do so. Absolutely. Okay, so we're going to put ourselves some square brackets like so. And again, we've identified that this is a cosine compound angle. It's this one over here. And again, I'm going to do the reversal of the expansion. So this is going to give us cos 60 cos theta. Remember, cos doesn't keep its sign, so that will be plus, and then here it will be sine 60 sine theta. And let me close my brackets like so. Right, so originally I had two terms on the left-hand side of my identity, essentially. Now I have four. Right, so I'm going to remove my brackets, and then I'm going to think carefully about what I'm going to do next. So let's just write this out again. Let's take away the brackets, remembering to change the signs of the terms inside. So this term, cos 60 cos theta, will become negative, and the sine 60 sine theta will also become negative as well. Okay, so sine 60 sine theta. There we go. Okay, brackets are gone. I've changed my signs. Have a look carefully at this second line of working. And can somebody tell me what you think the next thing is we need to do? What do you notice when you look at that second line? Hopefully there's something that you see going on there. Absolutely. There are some like terms. Good. Well done. And some special angles. Absolutely. Good. Yes. So both are going on in this diagram. There are like terms and there are special angles. So let's deal with the like terms first and then worry about the special angles afterwards. Okay. So what we're seeing now is something that we were first shown all the way back in grade 8. It's called an additive inverse, and it means that something adds up to 0. Okay, so if we have a look at the first term, here is the first term. I will put a pink circle around it. There's the first term. If we look at the third term, these are like terms. Okay, so cos 60 cos theta minus cos 60 cos theta means that there is no cos 60 cos theta term in our answer because those add up to 0. What remains, these are also like terms. So here I've got minus sine 60 sine theta, and here I have minus sine 60 sine theta. So when I simplify the ones circled in purple, what do I end up with, Matrix? What am I going to get? Can anybody tell me what I'm going to end up with? The pink ones add up to 0. What do I get when I simplify the purple ones together? Eventually I'm gonna end up with an answer, but before I get there, okay, because you've got to show your steps, you've got to show your working. Okay, so Dave says it's going to be positive. There we go. So whoever's iPhone is, sorry, I think you have told us your name before, and every time we forget to change you. But yes, minus 2 sine 60 sine theta is correct. So the way to look at the purple ones, Matrix, is like this. Okay, those are, as you all said to me, they are like terms. So if I said to you, what is minus x minus another x, you would all tell me that it is minus 2x, isn't it? Okay, it's exactly the same here. Exactly the same thing here. If you've got minus sine 60 sine theta minus another sine 60 sine theta, that gives you negative 2 sine 60 sine theta. Okay, and then once you have done that, then you are going to use your special angles. Okay, so the sine of 60 is root 3 over 2. We can see our answer starting to take shape now. Minus 2 times root 3 over 2 sine theta. And of course, 2 divided by 2 means that that's going to go away. And we are going to end up with negative root 3 sine theta, as we were meant to do on the right-hand side. Okay, how does that feel? Thumbs up, thumbs down? Are there any questions? So the cos doesn't fall away, Travis. When you say just falls away, it adds up to 0. I think, do you mean the cos 60 cos theta term? It adds up to 0. So I'm not going to write plus 0. Okay, I hope that makes sense. Yes, Morgan, would you like to ask something?
Yes, ma'am. Sorry. Do you mind
Mm.
explaining how it gets to 0?
Oh, okay. So again, let me just go back and use some basic algebra in order to be able to explain that. Okay. So the idea is this. If you've got minus y plus y, that's called an additive inverse. It adds up to 0. Okay. So it's the same thing with the pink ones. If you've got cos 60 cos theta minus cos 60 cos theta, essentially what you are doing is that you are taking something, all right, and then you are subtracting something that is identical from it. So in other words, if I said to you, what's 3 minus 3, you would tell me the answer is 0. Okay, so these sorts of things are important for us from grade 8, grade 9, but it's such a long time ago that we forget about them. So 1 is our identity for multiplication. So in other words, if we multiply something by 1, it doesn't change. 0 is our addition identity. So in other words, if I add 0 to something, it's not going to change. So I'm not going to write plus 0 as part of my answer. Essentially, whatever I had, I've removed the equivalent. So now it's gone. Okay, because it adds up to 0. Anyway, I hope that made sense, Morgan and everybody else. Okay, so Ovayo, how did the root 3 become negative? Because when I said minus sine 60 sine theta, minus sine 60 sine theta, that's what gave me the minus 2 sine 60 sine theta. So in other words, like when I had minus x, I've got minus 2x. That's where the negative came from. So in other words, I'm sitting at minus 1 on the number line, and I'm moving one place to the left-hand side. Okay, let's just see if there's anybody else. Nolwazi, nice big smile. Siam Tunda's happy. Bali getting there. Okay, so there's a few thumbs ups. Okay, all right. Now for the next bit, all right? So we've showed that cos 60 plus theta minus cos 60 minus theta is equal to negative root 3 sine theta. Now they want us to use this a little bit further. They want us to do something else. Yes, in Ntobizenhle, that is correct. So the 2 cancelled, but the minus didn't. Exactly, because it was negative 2 times root 3 over 2. So negative times a positive means that's why the negative stayed behind. Perfect. Good. Well done. So the next part of the question says B, hence evaluate cos 110 minus cos 15 without using a calculator. So when we see the word hence in maths, what does the word hence mean we have to do? It's got a very specific meaning. And if we don't do it that way, we're not going to get the marks. What does the word hence mean? Does anybody know? Palesa, go for it. Go for it. There we go. All right. So,
Okay.
There we go.
Doesn't it mean you have to use the previous formula? Doesn't it mean you have to use what you got in the first question to answer that question?
Absolutely.
Sorry, I'm muted, everyone. Sorry.
No problem. Exactly, Palesa. Exactly, 100%. Okay, so you've got to use your previous answer in order to do the next step. All right. If they say to us hence or otherwise, then they're saying to us, you've got a choice. Either you can use what you've just worked with, or if there's another way that you want to do it, you're allowed to do it that way. But if they use the word hence, we've got to use what we've just worked with now in order to be able to get our answer. And if we don't do that, we're not going to get the marks for the question. Right? So this ties back, oh, just excuse me. Sorry, I thought I was going to sneeze. So this ties back to what we were doing at the beginning of this lesson and last lesson, where they're asking us to evaluate trigonometric expressions using our compound angle formulae. Okay, so we're now going to go and have a look at cos 105 and cos 15. All right, and we're going to try and figure out what it is that they want us to do here without using a calculator. So bear in mind, okay, I'm just going to rub that out, okay, that what they are implying is that the first term here and the first term here are connected, and that the second term here and the second term here are also connected in a special way. That's what they mean when they say hence evaluate. What does the first term in A have to do with the first term in B? So in other words, we can see we've got the cos of 60 plus theta, then we see we've got the cos of 105. What is the connection between the two? What do they want us to realize looking at this? Anybody know? Thank you, Travis. Oh, there we go. Good, Asunda. Very nice. Well done. Yes, Palesa. Good, 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 good. Well done, guys. Excellent. Okay, and you know you're right, because if you say 60 minus 45, you know you'll get 15 as your answer as well. All right, so yes, they are implying, right, that theta has to be equal to 45 degrees. Does that make sense to everybody else? I know Palesa and Asunda answered quite yes, and then we've got to use special angles. Quite right. Does that make sense to everybody else? Okay, so often we don't know when they ask us to answer a question like this, what we're supposed to see the connection between. Okay, but it's the first term in A and the first term in B, and then the second term in A with the second term in B. That's what they want us to see. Oh, good. Oh, wonderful. Well done. All right. So now, when they say hence evaluate this without using a calculator, how do you think we should set this out? So what I'm going to do is just make some space here. This was part A. Here's part B. What do you think? How do you think they want us to set this out? Any ideas? Let's see what you guys are putting in the chat. Okay. All right, but if we do that, you are right to an extent, Nolwazi, quite right. You are right to an extent, but they've asked us to evaluate what this is equal to. So what they don't expect us to do is they don't expect us to go through the entire process of doing the expansion and then simplifying it, etc., etc. Right. So what they would want us to do is acknowledge, okay, that therefore, let's just see if anybody else. Yes, but they don't expect you to go through the entire thing all over again. So they want us to acknowledge that theta would have to be equal to 45 degrees. Okay, so now that we've acknowledged that, which is what a lot of you had already said, all we have to do is go and sub it in to our final answer. We don't have to go through the process of line number 1 and line number 2 again. All right, so here we would have minus root 3 sine 45. And now we can go ahead and use our special angle. So we know that the sine of 45 is root 2 over 2. And if you recall last year when you guys had done thirds, if you are multiplying something like root 3 with root 2, you're allowed to keep the root and then multiply the numbers together. So that would give us root 6, for example. Okay, so this would end up being negative root 6 over 2, and that would be our final answer. Maybe that was a little bit easier than you guys were. Yes, exactly, Nolwazi. You can go straight to your special angles. So once you've ascertained or written down that theta is 45, you can just go straight to subbing it into the last line. You don't have to go through the whole process again. Okay, was that a little bit easier than you guys thought? Okay, so Zintle, what we were doing, if you go back and look at the question again, all right, we've got cos 60 plus theta, and that became the cos of 105. Then we've got cos 60 minus theta, and that became the cos of 15. All right, so theta has to be equal to 45 because 60 plus 45 gives us 105. And 60 minus 45 gives us 15. Okay, so that means that theta has to be equal to 45 degrees. Okay. All right, any questions before I move? Interestingly easy. Good, I'm glad. So often we think things are going to be so much worse than what they are, and then sometimes we're a little bit surprised. Okay, so I've done lots and lots of talking now. Are there any other questions before I go on? And then I'm going to give you guys one to try. Okay, all right, so let's just move that guy out the way and move Yolanda down over there. All right, I do not expect you to do all of these. In fact, what I'm going to suggest, all right, is don't start with A because don't start with A. All right, so let's try B. Okay, if you are a fast finisher, let's see if you can do C as well, but we'll just see how it goes. Nontando, you're welcome to unmute and speak.
Nomfundo just disappeared.
Oh, shame. Maybe
And I
Nomfundo
saw, yeah.
will come back later. All right, so I'm just going to put that down there for you so that you've got that to refer to. All right, so remember, work with the left-hand side and make sure that it simplifies to the right-hand side.
You guys are doing really, really well. Well done, Trig. Let's go. We can do this.
And so conscientious on a public holiday as well. Hey, Yolanda. It's true dedication for
Yes, because
you.
I'm also like trying to have that vibe. It's difficult. I like the fact that we already have our formulas. So whoever is lost, I see you, Sitembile. I hope you are giving it a try. Just follow the compound angle formulas and just choose one. And then you have to choose the correct one. But I mean, you just have to follow that and then everything will just, solve itself. So just give it a try.
And sometimes the other thing that we've also, and I think you'd agree with me with this, Yolanda, sometimes we've just got to be okay with, sometimes you're going to get things wrong, and it doesn't matter if you get it wrong. If you realize you've made a mistake or it doesn't work, cross it out and try it again.
Yeah,
And if it
definitely.
absolutely, I mean, all of us make mistakes. All of us do. I mean, yeah, Yolanda, me, we all end up making, I mean, I make mistakes here on Watobe when I really wish I hadn't. But you've just got to not let it
Yeah.
get to you and just say, you know what, that didn't work. It's just a sign that I need to try something different or try it again. Maybe I forgot that minus times minus was plus or whatever the case was. But don't be afraid of getting it wrong. There we go. You're done. You stuck. Okay. So let's just see where, Kenzo, where are you stuck? What have you written so far? Can you tell me?
I think he
If
has written there also on the charts.
okay. When you guys say you're done, have you done both of them or have you just done one? Okay, so Kenzo's written on the chat. Okay, so let's just get this down. Okay, only B. All right, try. Okay, Tina, you've done both. Okay, cool. That's great. All right, Kenzo, I'm just going to write down what you've got so far. Oh, man. There's this button on the side of my pen, and then sometimes I press it by accident, and then it ends up doing this. Okay, minus.
That's normal.
Very irritating, I must say. I don't know why anybody would go and stick a button on the side of your pen that makes stupid squiggly lines all over the page, but then again, I didn't. Okay, and then you said cos. Okay, all right, but if you are using a sign, not that it really is going to make any difference. Okay, so Kenzo, when you get to this point over here, all right, sine 30, a theta plus 30, you're using your sine, one of your sine compound angles, all right? So sine keeps its sine, so you would have written this as sine theta cos 30, which I suppose you've essentially done in your first step. Plus, then this would be cos theta sine 30. And then what you've done is you've just done the first bit. You haven't done the second bit. Okay, so in other words, you have just expanded the first term. You haven't expanded the second term. So this term over here has become both of those terms over there using your compound angles. Okay, you've still got to do the expansion on the other side as well in the second term here. All right, so you would have to write minus, and then you would have to use brackets, and again, you would have to expand again. All right, so this would give us sine theta cos 30. Sine keeps its sign, so this would be minus, and then here we would have cos theta, come on pen, cos theta sine 30 like so. All right, so what was originally 2 terms has now become 4 terms, bearing in mind that we also have this minus that we need to deal with. Okay, so there we've gone and color coordinated it for you. Now you're going to remove your brackets, and we're going to end up with sine theta cos 30 plus cos theta sine 30 minus sine theta cos 30 plus cos theta sine 30 as well. And then we're going to look for like terms. Okay, so we can see, let's just get a different color. I don't like that orange. Let's go with this. We can see here that this term here and that term there are like terms. Similarly, let's just get a different color now. Let's go with turquoise. This term over here and the third term over there are also like terms. So the first and the third terms add up to 0. Okay, you found your mistake. Okay. C is a little bit tricky. Okay, we're going to go through C as well. And then I'm hoping I'm going to have a chance to at least do one of these examples with you guys before we say goodbye. Let me just move that down. Never ever enough room, no matter what I do. Okay, so first term, third term, add up to 0. The second term and the last term, the ones in green, those are the ones that we're going to be working with. Okay, so we've got two of them. So this would give us 2 cos theta sine 30. All right, and now I'm going to write 2. The sine of 30 is a half cos theta, and 2 times a half would leave me with 1, and that's why it would be equal to cos theta on the right-hand side. Okay. Someone had a hand up? No? Are we all good? Any questions? Did you guys get that right?
Yeah, I'm wondering how many
How did it
got it
go?
right.
How did it go?
I got it wrong.
You got it wrong. That's okay, Nkululeko.
Yeah.
The more you practice them, the easier they will become. All right.
Thank
But
you.
did you understand why did you get it wrong? Did you make your corrections?
Yes, on the third step, I said minus 2 cosine. Yeah.
That's okay.
That's
The more you practice, the easier
yeah.
it'll become. Okay. All right. So there are a lot of you that's saying you did get it right. Amu also got it wrong, but it's okay. Lenovo, that's Faheen. You say you're understanding it a bit better. Brilliant. Okay, let's go and have a look at the next one and just make sure, even if you didn't manage to do question C, it's going to be good for you just to watch this as well. You can always come back and practice these questions again later on your own as well. So let's just go through that as well. And then we can say, oh, good. Okay, in Ntombazintli, that's the most important thing. Okay, is if you did make mistakes, at least you figured out where you went wrong and what you need to do differently next time. Okay, let's just get question C down. And again, these questions are not about getting the right answer, because we know what the answer is when we start. It's all about our method the whole way through. Okay, so we've got cos 45 minus theta minus sine 45 minus theta, and that's supposed to equal root 2 sine theta. Okay, let's just go and bring these guys down as well. So we've got them to refer to. I'll stick that over there. Okay, and now we're ready. Okay, so those of you that did manage to do this, you can mark it as we go through it. So we can see that we're dealing with a cos compound angle. Cos doesn't keep its sign. So we would expand this as cos 45 cos theta plus sine 45 sine theta. Okay, then again, there's that dreaded minus that we need to be so very, very careful of. Brackets. And now we've got sine 45 cos theta. Sine keeps its sign, so minus cos 45 sine theta. Okay, the other thing that I just want to say at this point, Matrix, is that make sure that if you don't know your compound angle formulae off by heart, obviously if you can learn them off by heart, that's better for you. But if you don't, just make sure that you've got your formula sheet next to you and that you copy carefully. All right. I've seen with a lot of the matrics that I've taught at school, they don't use the formula sheet and then they end up writing their formulae wrong and then nothing works out. Okay, so if you are using your formula sheet, just make sure that you copy carefully. All right, let's remove those brackets. That would give us cos 45 cos theta plus sine 45 sine theta minus sine 45 cos theta plus minus times a minus is a plus cos 45 sine theta. Okay, so now if we look very carefully, all right, do we have any like terms? Let me not say anything. What do you guys think? Do we have like terms? Okay. Yeah. So the answer to this question is no, we don't, and yes, we do at the same time, which is a bit of a crazy one. As it stands right here, we don't have like terms that are obvious to us in the same way that these ones were. All right, or when we did this example at the front, they're not obvious like that. Okay, but when it comes to the cos of 45 and the sine of 45, sine 45 and cos 45 are equal to one another, aren't they? All right, they're complementary angles. They add up to 90 degrees, and they're part of our special angles. So the sine of 45 and the cos of 45 are identical to one another. When we apply our special angles at this step, we will see that we do in fact have like terms that we're going to be able to do something with. If we don't apply our special angles, we're essentially stuck here with nothing that we can do. Okay, but as soon as we apply our special angles, then we're able to get going again. Okay, so remember the cos of 45 and the sine of 45 are exactly the same thing. So let's do our special angles next. Okay, so this gives us root 2 over 2 cos theta plus root 2 over 2 sine theta minus root 2 over 2 cos theta plus root 2 over 2 sine theta. Now it's far more obvious. We have indeed, let's just, sorry guys, just move all this out the way. We have indeed got special angles. Okay, so the first and the third will add up to 0 again. The first and the third will add up to 0 again. Right, but the second and the last are like terms that we can add together. Okay, so if I've got root 2 over 2 sine theta plus root 2 over 2 sine theta, it means I've got 2 of root 2 over 2 sine theta. Okay, and then I can simplify from there. Okay, so combining my like terms together, the ones that obviously don't add up to 0, I've got 2 of root 2 over 2 sine theta. And similarly to that previous example that we had done, when we say 2 divided by 2, that's going to simply leave us with root 2 sine theta, like so. Okay. All right. How did that go? How do you feel? Is that making sense? Lokomelo, do you have a question you want to ask? Shame, I don't know how long your hand's been up. Sorry, I've only just seen it now.
Yes, ma'am. Ma'am,
Go
I do
for
not
it.
understand how we got root 2 over 2. Because when I use the special triangles, I get a different answer.
Yes. Okay. So when you are working with the triangles, you will
Yes,
not get root 2 over 2. You get 1 over root 2, don't you?
yes, ma'am.
Yes. But 1 over root 2 is exactly the same as root 2 over 2. All they've done is they've rationalized it. Okay.
All
So
right.
if you want to work with 1 over root 2, there's absolutely nothing wrong with that. So when we
All right.
rationalize, we would do this. And then we would multiply the numerators together and we would end up with root 2. And then when we multiply the bottoms together, that's where the 2 comes
All
from.
right.
So yeah, so that's fine. Not
All
a
right. I
problem.
completely
Okay.
understand, ma'am. Thank you.
Good. No problem. Sharon, you got a question?
Ma'am, hi. It's not really a
Hi.
question, but can you please scroll back up so I can
Yeah,
take a screenshot?
Of course, with pleasure.
Thank
Is that
you.
enough?
Yes, it is.
Okay, perfect. Then at least the whole question is in. Okay, then I see there's a couple of other people with hands up. Okay, there's the poll. Dave, do you want to ask your question before you disappear?
Hi,
Hi.
ma'am, instead of multiplying the 2 divided by 2 sine theta, I just added them and I got the same answer. Is that like fine or?
I didn't hear what you had said. Just say that again, please.
Ma'am, instead of multiplying the root 2 divided by 2 sine theta, I just added the root 2 divided by 2 sine theta to the other one.
Yes,
absolutely.
absolutely. Because if you add something to itself, it's the same as timesing it by 2. So yeah, not a problem.
Thank you,
Not a
ma'am.
problem at all. Pleasure. Any other questions that you guys want to ask before we say goodbye?
Yeah, we're running a bit late, so
We are running a little bit late now. And
Mm.
Nkululeko says, please explain step number 4. 1, 2, 3, 4. Okay, so Nkululeko, just very quickly, we have written the cos 45 in front of the cos theta in the first term as a special angle, as root 2 over 2. And I did that with all the special angles. Okay, so if I just go back and highlight them for you very quickly before saying goodbye, this is a special angle. That's where the root 2 over 2 comes from. In the second term, sine 45, special angle, that's where that root 2 over 2 comes from. Okay, the sine 45 over here, that's where that root 2 over 2 comes from. And it's the same thing in this last term over there. That cos 45 was written as root 2 over 2. Okay.